Hello guys, and welcome to this practical session. My name is Ngane Emmanuel and I'm a software engineer, and you're watching a practical session which is part of a series titled Building Scalable, Secure, Fault Tolerant and Low Latency APIs using Java and Spring Boot. Today we are going to be looking at practical session 4, mass assignment and privilege escalation. In our last video, we talked about DTOs, their importance in protecting against mass assignment and privilege escalation. We defined those terms and we talk about a lot of other things. So today we are going to be looking at the practicals as promised. If you are new to the channel, please go back and watch previous video to get context. We are in about more than 10 videos. We're about 12, 13, maybe 15. And in this lesson, this is lesson 6. This is a practical session for lesson 6. And you can also subscribe to the channel, comment your questions that you're going to have at the end or during this video. Connect with me on my socials in the link below, and the repository where all the code and the documents, the notes are found is also left in the link below. So do check it out, start the repository, clone them, and follow along. So let's dive right in. So thus far we've created a basic API which they are very unsecure, and today we're trying to look at what privilege escalation and mass assignment will can occur. So we have this particular endpoint here which is a basic user login, and it binds to a user, and this already shows how unprotected it is. However, if you look at what we do here, we actually save ourselves some trouble by just getting the username and the password, and then we verify in the service layer against these two parameters. So what we are going to do is we are going to create a put. We're going to create a put mapping, and what this is going to be is /update, right? What we want to do is want to create an update endpoint which is going to be public, and we're going to update user, right? Now, in order for us to usually this is how it's done. As you can see, we are binding the user entity, which is the user object, directly to the request data, and we are going to take this and we're going to call user service, right, dot update user, right? So we can just, and then we're going to pass in the user. We're going to return this, and we're going to return a status code at the response entity, response status, http.ok. I don't know if I just updated something. I don't know. Okay, so that's okay. So this one is created here, so this will be okay. So that's 200. The update is successful. We're going to create now this service. So we're going to open the service class. If you're using IntelliJ, basically you can highlight, you can hover on top of it, and it's going to say create method in service, user service. In other words, you can open the service class in your service layer and you write this function for it to create it. So again, like I told you in the last sessions, I'm not teaching you how to code. I'm teaching you the essentials here. So what we are going to do is we are simply just going to call user repository. So we're just going to return user repository.save user, and the save method here will find the user by the ID and then update the field. So if you have any updated field, it's going to use the primary key to find the user. In this case, is the ID, as we have defined in the model class, which is the ID, and this becomes our primary key. It's going to use that to find the user, and it's going to now update the fields which have changed, right? So it's going to compare. So normally, if you're going to do an SQL, you're first of all going to do select all, or select all from users where ID is equal to, right, user ID, right? So you're going to put the user ID there in the question mark section, and then you, after that, you will do update, right? Or you could simply just do update update all. Have I forgotten SQL queries? So we have select, update. I think it's so you're going to get a username, yeah, something like that. So we're going to get update users, set first name equals to that, second name equals last name equals to that, user's name. So basically all the fields are gotten from the user class. As you can see, we have first name, last name, username, email. Okay, and that's what we are going to get. So this is what you would do rather. So you will not select first. So basically, I wanted to explain to you that what it does is it first of all selects this, right, and then updates it. But that's manually. Normally, if you're running a query, it will just update it directly. Okay, but in this case, it does more than just this query. It checks for differences. So it doesn't just like update the fields, right? So it check if this username, so which is why I wanted to do the other one, because it gets this first, right? Then returns and then creates another user object and then check for like differences, which we are going to see when we are doing the implementation with the DTO, at least a version of it, then before it updates the user itself. But for now, we just use the save method, and what this does is it compares the user passed object data to what the entity, the database object that is being returned, that is being found in the database with that user primary key, and it compares the data. Whichever have changed, it updates the database table or the user with the changed data, the updated data, and then it's going to return a user, which we're returning here, and we're going back to the controller and we're returning here. Okay, however, if we could do a try, right? We could say we have issues here, right? We could do a try, and we could catch exceptions. We could try, so excuse me for the background noise, kind of walking here in the house here. So we are going to try, and we're going to catch a basic exception, and what we're going to do is we're going to throw new user not found exception, or bad credentials, or we could simply just throw a new exception. We could just throw a one-time exception here. Okay, so we could throw a one-time exception, and we could catch the runtime exception, the global handler, exception handler, runtime. Not class, and we're going to respond HTTP the status error, and we're going to simply just return the message, right? So internal server error, and So you could catch multiple exceptions. Basically, you put in a try and catch. You get like a user, you get the ID, and then you check all that stuff. So we just do something like this so that whatever error, whatever exception, say if the user is not found, we are simply just going to return a runtime exception, right? Runtime exception error while updating user. We don't return the message, we just get there. Right? So, yeah. Okay, double. Okay, so that is it. So this will, what I'm going to do is I'm going to open Workbench. I hope my SQL is running so that we see the user that we've gotten. Okay. So there we go. And okay, actually, can just test look at the data. So this is the data that we sent, and we've got the user with the ID 1. So what we can do is we can get this very data. Okay. Oh, this is not the data. We could. All right. So. So the ID of this one is 1. How is it 1? So let's check that out. Let's check user. So there are 2 users, John Doe 2. So the ID is 2. But well, we got a return statement. And the ID is 1. So what will happen is we can. So what can we do? We can just create a get request. Okay, so what I can do is I can create a simple get request that is going to get all the users. Is this right? So we simply just create like a get request. So sorry for the delay. I'm just going to quickly create like a get request. So like the users. Okay, so no users. So just like a get mapping, and that's all. We want to get all users, and so health check. So public list all users find all. Yeah, and we're going to get return. We're going to call the service which is user service dot find dot find all users. Or let's just say the better statement will be get users. Right, so it will be get users. That's small g, and what that will return is all the information. And I also want to do the implementation for this class in such a way that it is going to take an argument, right? And this is not how you do it, but just for the sake of testing, is that it's going to take an argument of, let's say, request body, It's going to take an argument of the user, right? And it's also going to pass the user there, so that in the implementation we're going to pass the user and we're going to get the user. What will happen is we want to get, and this user will be the user in this area checking for permission, right? So we are checking if this user has permission to get all the users, and we want to give this user permission if they are admin, right? So the first thing we're going to do is so we're going to say if user dot get role. Okay, so get role, and we realize our role is not added there, so we want to add role to the entity. So you go to the user entity class, and we want to do private. Let's just say private. Let's say it's a string, and we want to do role. Right, so it's a user. Okay. You could add multiple rows. You could put the list of rows. You could, and then the checks will be different. But we'll just keep it simple. So this one, it's also not nullable. So I'm going to put column, and we're going to put name row nullable false. Right. So it's also not nullable. Then, okay. And what we want to do here is that we're going to do user.getRole, right? And if it is not equal to if it is not equal to admin dot equal to, yeah, that's what I want to do. So I want to use the method equal admin. So I want to use admin. If it is not equal to admin, so I want to do this, the not sign there. We simply want to throw not the user not found exception, one through user not authorized exception. So by now you should get a hang of exception handling and understand why we throw exception and the usefulness of exceptions. So we can do user not authorized exception, we can do not authorized to access this resource, and we can treat the dependency by creating the exception itself. We create a new exception class, again the same procedure, and we create the user not authorized exception, which is a simple string, and we're going to handle it in the global exception handler. We're going to have exception handler. So what it's going to do, you're keeping the runtime at the bottom there so that it handles everything else. Exception handler, and we're going to create the user not authorized exception, and what this is going to unauthorized, and this is also going to do public, and handle user not authorized exception. And what this does is handle the unauthorized exception for us, and we're returning the appropriate status code alongside, and we're simply just going to import this class now into this into that. So if the user is authorized, what we want to do, so this is a very interesting design principle which is returned early in your functions. So most of the time, especially in this cases like this, you want to check for the bad the failed version of your method, the cases that will fail. You want to fail it early enough so that you return and save yourself some processes. What you don't want to do is write a bunch of implementation code before all of this right up here. You don't want to write implementation code up here, and then you do implementation before coming right down. What happens is that all that process up gets executed and takes a lot of memory and processing time, only to come and fail the user. But if you can check for this early on, you could return early and save yourself some processing, right? And this is part of those principles. These are just part of the design method when you choose when implementing your solutions that allow for speed. Okay. So once we have once the user is an admin, what do we want to do? We simply just want to return um, m.find all, right? Right, yeah. So this is going to return a list of users. So this returns a list of users and user ORM, and it's going to return a list of users. And that's all we have to do here, right? So this is a built-in method, define all. We don't have to create a custom method there. And that's it for now. So what we have done thus far, we've created our update, which will send information, and I'll find all. So if I go ahead and run this, okay, so this should run perfectly. Right. So if I take, so what happens is, if I take this information here, this particular one, and I create a get request, okay, um, so I'll create another get request. I think okay, we are done with the, so we're done with this one. So API version 1, so we want to put users login, so register not register, and I want to do so just users here. So it's a get request, and what I want to pass in the request body, which is in raw data form, I want to pass in this particular user body type, essentially, right? So basically we're passing the user object, but this is not how you do it. This is just for the sake. I'm mimicking verification, how you send potential user information, but most of the times your user information, which we're going to see in the authentication authorization classes up ahead, are going to be just very limited information, limited just in the form of, say, the user name, the user email, or the username, right? So it's most likely going to be a token that contains the information in the payload section. So we have the information, we have the user here, right? So assume that this is the information we are sending, and in this case, the user role is not given, okay? So actually what I would do here is I'll create a new user instead, and I will change this implementation, excuse me, while I'm there. So what happens is that I want to change this implementation for the register user to set the user. So what I want to do is user set role to user, right? And then save the user. So we run that. So stop and run. And I want to create a user because in the last implementation we did not include role, and now our users don't have role. And I want to just create a new user. This will be John Doe 3, John 3, John Doe 3, John Doe 3 for the username, and John Doe 3 and 1 to 3. And we are simply just going to send it that information. And as you can see, it comes now with the role user. And this is the information now we want to take and pass in our request body for this particular request, so that when we send the get request, this is a get request, we want to, it will tell us unauthorized because we are acting as a user here for the role, right? So not authorized to access this resource, as we saw, as we handled it in our exception class here. So I cannot return all the users, okay? Now, that's say our basic implementation, something like that, right? And I want to show you what mass assignment is all about. So the first thing is we are going to check mass assignment. Now remember that we did not for the first two, where are they? For the post. So we did not, we had something like this, John Doe 3, John Doe, yeah, John Doe. We did not, in this particular case, and this will be um, user number one, we did not add the role when sending the request for the first request. So what I want to do is update data, and essentially what I want to do is HTTP so user.update. So update, okay, and what I want to pass is the body. Now mass assignment talks about you adding extra fields that you're not supposed to. Normally, this is the field we are accepting for our users, right? So we want to update, we don't want to pass in. So in our documentation, say we documented just this first, the first three, just this the fields, just these fields as our input parameters in our request body. Okay. Now for mass assignment, you first of all find fields that our API takes, such as role. Okay. Let's say user, such as role, and then you add it to the request itself. Normally, when we document, we only document these ones, right? So in our updates, in fact, we say we don't even document. So when we are documenting or updating, we are not updating. We are not when we are updating. Yeah, so we update the first ones and the password. So once we update the password, we're going to have a different mechanism for that. But say for now, we keep it basic, and when we send our update, we only document these first 5 fields, right? What happens is that we can use, I think it's force, FUZZ technique to discover additional fields, right? And then add these fields to our request body that allows us to change and process this data in our database. Okay, so our user, normally we are not supposed to be able to update roles. As you can see, we update role in our backend. It is developer controlled. It's a developer controlled field rather than a user controlled field. So but in our backend update, we did not implement these rules for exception. We did not properly validate. Okay, and what you can do is that you can add a field which is a role, and have it update the user. So what you see is okay. So what this has happened, it has created a new user. But what I don't want to do is create a new user. I want to create. I want to. So I want to do ID. So again, we have the ID here. We want to do one, and that's there. So what I want to do is update that user with the ID 1, 2, and then it's going to update the role field to user. Okay, and that's mass assignment, basically passing in parameters that we are not supposed to as a user, that we're not supposed to have access to, right? But just because we do not limit our parameters and we're binding the entity directly, where is it, into our controller. So in this update section, we are using the user entity, and if you look at the user entity, it has all the fields, and it gives us access to update all these fields, including the ID itself. You can update everything, but the ID is auto-generated, so you can literally change the ID and then you choose 4, and it's going to update the information for row 4, or the row with the ID 4, and so on and so forth. So what you want to do here is protect this particular endpoint by using something called a DTO that allows you to specify exactly what data is being used. Now, before we jump into DTOs detailing, I want to also show you another vulnerability, which is privilege escalation. So because we have access to this update rule, right, what we can also do here is update this to admin. Now remember the previous time when we try to get the data, we had no access because it is of user. The role here is of user. Now, if we change, where is it, and update this data, you know what? Let's get the, and we'll get this one. So if we use this data, let's say we use this data, okay, and we say, so we are getting the data, and we want to, in this case, this is the user, okay. Right, so we have unauthorized. Normally, I did not actually implement it perfectly, but it's still the same thing, because if we're supposed to get the admin, we don't get the admin for the user data. We actually look for the user. We create a variable, and we have data. So db user, and then we'll find user by ID, and then we are going to use the db user here rather. So user.get role, db user.get role. In optional. So db user, okay, this returns an optional. So we have to put a dot get here. Just put a dot get. Normally you check for dot is present if it's present and return, but just for simplicity's sake, we're going to put the dot get here. You know what? Let me put it here. So what we'll do there, we'll have if db user dot is empty, right? We want to return through user not found exception, and if it is not empty, then we want to get the db user.get role. Dot get role. There we go. All right. So that's what we are doing here. So this is a better way of doing that. So that actually explains a lot, because now you're getting the user and you're verifying against the database. This is typically how you do it. Because the other way, we could simply just send anything here, and we could even just send the admin here, and it doesn't need to verify the database. So let's say we have like a implementation like that, which sounds more plausible. So what we can do now is, if we check for the user, again unauthorized, because this user, although found in the database, he has a role as user, right? Now, what if, so if we check admin here, if we do admin here, it's still going to give us unauthorized, again, because it's checking from the database. Now, if we go to the update section, update, and let's see, so in the get, what are we getting? John Doe 1, and in the update section, we update these two. Instead of user, we update it to admin. It's now admin, and we go back. What we've done is that we have accepted, because we did not secure that endpoint properly using DTOs and validation. We have accepted and been able to change the privilege of this user from a normal user to an admin role. And this is what we call a privilege escalation, because now the privilege has increased to an admin. So we can, with an admin role, what can happen is that we don't even need to send that particular field, right? We don't probably even need to send any other data. We can just send just the ID, okay? And with that particular field, we can get all the information, okay? We can literally get all the information. Why? Because it's now an admin level user, okay? It's now an admin level user. And with that admin level, it allows them to get access to things that only this particular with users with admin level access can get access to. And by escalating their privilege to an admin, they have access to all the user information, and they can now use each user information and get whatever they want to do with that account. And that is how you do mass assignment. We have demonstrated that, and privilege escalation. These are control tests. Now, how do you protect against mass assignment and privilege escalation? The first thing is you always want to use DTOs. So we're going to create a folder called DTO, package, bring DTOs, right? And we're going to create a class called